popular PCAP. It's one of the most, I guess, well-known PCAP analysis tools out there. It's free. In this description you see here is basically straight off of Wireshark's website. They say they're one of the world's most foremost network protocol analyzers. It lets you see what's going on in your network on a microscopic level, and it's completely free, open source. So don't try to go on eBay and try to purchase a license for Wireshark, because there really isn't a license for Wireshark. It's completely free. Just download it. And a couple things that they listed as you can use this for. You can use it for live captures and perform offline analysis. You can do deep packet analysis. You can browse packets, extract files, and even decrypt traffic if you wanted to. So starting out, I'm not going to get into how to install or download Wireshark. I'll assume that you can find your way to the website. Basically, it's wireshark.org, and you can download the software and get it going. And it's fairly straightforward once you install it. You get to this interface when you open it. First off, you're going to see that it's going to list out a list of interfaces that your computer has available. So it may not look exactly like this. This one has a lot of different interfaces, but for the most part, you should at least see something like a local area connection or a Wi-Fi connection. And if you have VM tools installed, you'll see these VM adapters here as well. And what these really mean is that when you're opening Wireshark to capture network traffic for the first time, what you want is pointed to an interface. The easiest way to explain it for people that's not quite familiar with it is you got your wireless internet connection, right? And you can also have network LAN Ethernet connections. And depending on which way you point it at, that's what Wireshark is going to try to capture based on what you point it to. So if you point it to the wireless network interface, it's only going to try to capture the wireless connection. So in case that you use both landline and wireless connection, it's good to know which one you want it to capture. So starting out, it's real simple. You open up Wireshark. You can just double click on any of these interfaces and it'll just start capturing traffic. So before I dive too deep into it, so capturing traffic, there's really a few methods that you can do. One simplest, if you just hit the capture button straight off after installing Wireshark, what you'll be really capturing is really at this first level, which is the host machine. And if you're just using it to, let's say, browse the internet, which I just have a cloud as a generic icon, you're going to be able to capture basically everything you're doing on your laptop. Like, let's say you're browsing Google and you hit the capture button on Wireshark, you will see the traffic coming in, that you'll see everything, the network from your computer to the cloud. But for more sophisticated, like you're trying to actually see what's happening on a certain device on a network, then you may need to set up something called a span or a mirror port. And what that means is, so if you have an existing network going through a switch, by most standards today, that switch no longer broadcasts the network traffic through all the different ports, whereas traditionally in the old days, they were hubs and they just broadcasted in every direction in all the ports, and it was very easy to capture traffic. But nowadays, network switches are more efficient nowadays. They only go to certain network designated ports. So when you plug into a switch and you hit Wireshark to capture the traffic, thinking that you're going to capture all the traffic on that switch, that's actually not true. Those switches actually need to be set up so that you can redirect the traffic to the port that you have plugged into to capture all the traffic, or just certain traffic that you designated out on that switch. So let's say you want to capture all the traffic from the cloud going to the switch and all the users there. You have to set up ports, which are redirected to that port, which then goes to your Wireshark. Another method, third method here, is that In case that you can't get to the switch and you just want to capture traffic between 2 points, it could either be the switch or the cloud or device or between 2 devices. You would have to put a physical tap in the middle. And this could be actually as simple as the using a network hub, the old traditional network hub, which basically just broadcasts the traffic to every port. You can use that, just connect two devices on the network hub, and then your third device, which would be your computer sniffing port, and it'll just capture the traffic. Or you can buy dedicated taps that they sell like on like Amazon stuff.
Video. It was not the kind of production values that you would expect for such a moment in time. What he said is interesting in the sense that they have now regrouped Qatar. They are, Qatar obviously is the nation that's closest to the Taliban. They're going to try to
Bill's microphone.
Yeah, it's just say we got a hot mic. I can mute it.
Oh yeah, if you can mute it, that'd be good.
There you go.
All right. I'm sure Bill appreciates it. Okay. So now we're on the next one. So in case you didn't feel like capturing network traffic for yourself, you can always get traffic from somebody else where they already have done it for you. You can download samples on the internet. I will post these into the chat at the end of the presentation. But there are some out there. You can easily Google it. But I'm going to give you a few that's I thought was really nice. The first link basically is ICS related protocols. The second one is basically Wireshark generic sample captures. And to open these, you basically just go to Open Wireshark, file open, select the PCAP file of your choice. If successful, you will see the traffic populates. So here, with one of the samples it's open. I have Telnet, and you can see all sorts of different things. And what I want to highlight is some of the features in Wireshark, the interface. You can see the time. There's source IPs, destination, protocols, more source MAC addresses, destination, source ports, and source destination, and destination ports. And here is basically all the network traffic information that you'll see per packets that you have selected. So one of the things, if I actually, most of the times that in the timestamp here, you might see like a really weird number, and it doesn't really quite make sense if you're trying to make it into more of a, I guess, human readable format. You can actually get it back into the original time date stamp. And to do that, you basically would go to View, Time Display Format, and then just change the display here. And that really puts it back into a really good format so that if you did do a packet capture yourself, and you're kind of confused by looking at a lot of the time synchronous timestamps, and it's hard to figure out, what time is actually trying to say, you can actually change that and put it back into more of a date time, in case your Wireshark does not do that by default. Let's see. And then saving PCAPs is also very simple. So, and a lot of this, like I said, I'm going to do a live demo of this at the very end, in case this is a little bit hard to follow. Saving PCAPs, you can also do save PCAPs. So if you did a live Wireshark capture, you can hit the red stop button up here, and then you can save a PCAP of your capture, and you can name it anywhere you want. At the same time, if you're working with existing PCAP and you did a filter, you can also save the PCAP of just the filter section that you have done. And that's actually pretty nice in case you have a very large PCAP and you just wanted to export like just the HTTP traffic or just two IP nodes that's talking to each other, and you just want to give it to somebody else or save it for your own analysis later. Okay. Let's see. One of the things I want to go over is real quick is also just the OSI model, in particular to protocols. And what that is basically, for those who aren't familiar, is basically just a stack of the network layers, so that you can kind of see the different layers within the network. Starting out, I kind of omitted the physical link because that one was just something you usually don't see in Wireshark. So this is just all pertaining to the protocols. You'll see, starting from the bottom of layer 1, you'll see Ethernet as an example, IEEE 802.15.4, which is a wireless protocol. Then you go up to network layers, the IPs, transport, TCP, UDP, session, NetBIOS, presentations like the ASCII, JPEG, and application, which is the Modbus, HTTP, FTP, and Telnet. For the most part, in Wireshark, you'll see in the next slide that Wireshark does it a little bit differently as far as display format. And what you'll see is that they kind of shrunk it down a little bit, and the layers are kind of inverted, I guess, just for simplicity of how you can track it when you go through trying to analyze the packets. So Wireshark at the top here, they actually have the data link layer, followed by the network layer, and then the transport, and then the application. That's just something I want to point out. So, and then I'm going to go through each one just to kind of show that a little bit more, so that kind of makes sense. What you have starting out in the data link layer, what you'll see is the MAC address if you expand it. And Wireshark does a really nice job. If you click on it, it actually just highlights everything. It tells you that it believes that that's where the relevant information is, versus you just trying to look at the raw, the hex here. And there's also a nice display of ASCII bytes, in case you want to see if there's actually legible words in here. And then we go to the next one, the transport layer. The network layer. When you expand it, it'll show you all the information that it knows about it. And for the most part, you're really only concerned about the IP address. And same thing, if you click on it, it shows you the relevant packet bytes highlighted. The transport layer, which shows you, the ports, and then other relevant information if you really want to dive a little bit deeper. And then this is where you probably spend most of your time if you're doing packet analysis, is the application layer. And in this example, it's Modbus because we're doing obviously ICS related presentation. So I'm showing you one that's with Modbus, and you'll see that Wireshark has already basically understood that this packet is Modbus and already broken down the individual functions, references, and the bit counts to show you in Modbus. Okay. Now, when we get to filtering, one of the coolest things that you can do with Wireshark is that you can actually filter that really big PCAP that you have, down to something that's a little bit more manageable and something that you're more focused on. And rather than trying to teach you more of the commands like some of the other classes do, I thought it was really more intuitive to show you the more of the graphical interface way. And what you can do is if you have your mouse highlighted over a certain spot, depending on where you're at, you can right click and you can apply or prepare a filter. So in this case, I wanted to filter by a source IP address. So I can move my mouse over the IP address right over to source, or I can come down when I'm looking down at this interface down down here and right click on the source packet there too. When you hit select, it's actually going to know that you just want that particular filter applied. So in the next slide, you'll see the example. So when you hit apply, it automatically populates that in there, and it says IP.source equals 141.810.24, and excuse me, and then all my packets are now filtered by that particular destination. You can also do the same thing with more complicated like application layer protocols too. So here I did one for the function code. So this could be important information to display if you were to try to analyze something within Modbus, right? In this particular, let's say I want to see, who's actually writing on the Modbus protocol, and that's function code 15. And then you can basically then go through and do some analysis and just make sure that all the IP addresses that you see, is actually from legitimate source IPs that's actually supposed to be performing this write command to your designated devices. So this is where it can be pretty useful. So so you would like, one of the other things you could do is once you filter it, you can also sort it by source IP or destination IPs or MAC addresses, and then that way you can quickly scan through it and look to see if there's any rogue devices that's trying to communicate with your devices. You can also search by strings. So let's say in this case is a Telnet session, and you're looking for a particular website or particular words like user or password, or even if you know your password and you just type it in, and just maybe it's in one of the Wireshark capture that you did. So this is all good for finding clear text transmissions or certain keywords that you're looking for. Let's see. Yes, I did. Yep. So to get to the search text, you basically just hit this little, magnifying glass thing, and it will do the search string. And you click on string, you just type it in, and just do a search. And here the example, it found the zing.org in this example. You can also search by hex. Another pretty useful feature. So if you were to look for something that's not quite built into Wireshark, and Wireshark doesn't quite understand what it is, and you happen to know the hex value to look for, then you can type it in here, and Wireshark will find it, and then you can come to the conclusion, certain packets are maybe meant for another protocol, or maybe this is a indicator of compromise that you got from a report that, some sort of a hex string comes through a PCAP, and then you can do your analysis and flag certain packets for deeper inspection, maybe by another group, or pass them off to your SOC for those folks to dive a little bit deeper to see if this if this needed more validation. Another feature in Wireshark is statistical endpoints. You can get through this by clicking on the statistics menu and go by endpoints. And this works for basically the Ethernet protocols. And this is good for basically seeing, how many devices does Wireshark or within this packet capture, you actually see. So it's good to see, how many devices that is on a network, and you can do a quick glance, is there anything that doesn't belong, or maybe something that's missing. So it could be used for multiple cases. one for maybe like inventory tracking. Another case would be, trying to understand the network flow of the network. You can see the packets that flows into that address. You can see the packet that goes out of the address. So depending on what you see, you could maybe identify, your high throughput nodes, and then you can also see who are communicating the least, right? So let's say if you were to try to find a new adversary that's making a connection and he's not making too much noise, you can maybe use this as a tool to kind of filter out which devices to focus on first based on the least amount of traffic, because those will be the guys that maybe just doing a light level of poking around, and maybe you can start with that and apply those as a filter and see, what kind of traffic that particular IP address is trying to do. And one of the most useful features in Wireshark is actually you can follow the TCP stream. And this is really good because you can really see, the flow of all the packets consolidated nicely in one interface versus you trying to click each packet and trying to manually follow along, the communications of potentially thousands of packets going back and forth. And to do that, you basically right click on one of the packets and then just say follow TCP string. And here is an example of a Telnet session. And what you'll see is basically what Wireshark has put together. The reason I pick a Telnet session is because it's more in clear text, whereas typically you'll see a lot of more computer language looking text here, where it's just 1s, 0s, and a lot of symbols, and it won't make a lot of sense. But Telnet looks pretty simple. And there's different colors. So red is basically the source, who is doing the initiation of the communications, and then blue is the response. So in this case, it's a client initiating a connection to a server, which then talks back. And to follow along, you can kind of see that, we can see login information here, and it kind of looks like there's a lot of repeats here, but what's really happening here, to make a little bit more sense, the WiCyS fake, the way it is that if you ever use a Telnet session, when you type it in, that's a response, right? So the F in red is the user typing F, and then the F in blue is the Telnet sessions sending back feedback to display. You enter the character F, so that's why you see duplicates here. So for you, when you're doing this Wireshark analysis, you just want to make sure that you want to understand the colors. So really, it's just FAKE is what's all been spelled out, not actually two Fs, two As, two Ks, and two Es. And then the password, and then the password is user. And you don't see the blue feedback because if you've ever used a Telnet session, you don't actually get the keyboard feedback. So the password here is just plain user, and it's only typed in from the client. And then you can see that this session was successful. User was able to log in. They got the welcome screen. Looks like they enter some directory commands. They're able to get initial directory of the Telnet session. Another interesting feature of Wireshark that could potentially come useful for you is you can extract HTTP files from Wireshark. And to get to that, you basically go to File, Export Objects, HTTP. And if Wireshark is able to see HTTP traffic and see the objects, it will basically show you the object listed. And you can actually extract it all into a folder for yourself to see, hey, what kind of stuff can you see? And mostly it will just be, like images, HTML web pages, whatever the sample file had. Okay, so then now on to a little bit more deeper dive, a little bit of more packet analysis, and some of the things that you can do is
No, that's not what we want.
with packet analysis.
That's fine.
Let's see, I think someone else gone on mute. Okay, good. You can identify basically unsecured traffic, most likely just clear text transmissions. You can do network characterizations, which is looking at IPs, MACs, devices, protocols, the bandwidth. You can perform analyze the protocols, like how does the protocol work, the identifiers, the functions, the values. You can also try to do find malicious activity, based on the analysis, are you under a DOS attack? Is there a man in the middle? Do you see rogue IPs, unknown ports, exfiltrations? And these are all just a small sample of packet analysis, reasons why you would do packet analysis. And then you can also do a protocol analysis. This is more a deeper dive into, if you really try to understand how does the protocol work if you're dealing with a brand new protocol, or you're just trying to understand a existing protocol like Modbus. And some of the things you can do is identify, how does the protocol initiate a connection? The functions of the protocol, are there auto discovery? Is there a reset? How does the protocol read values? How does the protocol write values? And those are some of the questions that you can try to answer when doing that protocol analysis. All right, so, and then you want to try to also understand the application. So starting out, a lot of this is going to be fairly new, especially for the intro level folks. And what you want to do is basically just start out, here's an example of Modbus. Again, you see that in this particular packet, it looks like Modbus is saying there's a function code, it's write multiple protocols 15, there's a reference number of 5, a bit count of 1, byte count of 1, data of 0. Looking at this, it doesn't really mean anything. I don't know what that means. And what you should do is basically, the internet is your friend. A lot of this information is already out there. Unless you're working with a proprietary protocol, you're probably not going to find that information. But more open protocols like Modbus, you can find information that's already out there. And I would suggest, just doing a little bit of a light level homework. Even maybe you're looking on some YouTube videos that might have people trying to explain to you exactly how these protocols work. Here is just a quick image from Wikipedia. It shows you, these are all the different function codes that Modbus does, but it doesn't still quite explain, what does that even mean, right? But at least it's a start where you can kind of see, okay, it did a function code 15. This comes over here. It looks like it's something to do with physical coils. But for me, I should know, like, that's basically just telling that Modbus you're going to write to a certain register. If we go back, trying to explain it a little bit, I'm not going to go too deep. Where it's basically saying that, it's writing to reference register 5 with just a 1 register there with a data of 0. And that's all it really means, is that this particular packet is just trying to write the number 0 to register 5, is all that means. Okay. And then I'm kind of going to go over a little bit of Zigbee too, because that's also another industrial type protocol that you'll probably see out there. This is more of a wireless protocol. I just want to kind of show this to you because it's a little bit different how Wireshark sees it. But at the same time, it shows you that, you can also deal with wireless protocol. It doesn't have to be a landline or a internet protocol. So with Zigbee, you can also look up the information like one of the links I provided here on the slide, or you can look up, there's various sources, documents that explain exactly how Zigbee works. But some of the highlights here that you'll see, it's built on top of IEEE 802.15.4 wireless protocol, which handles basically how exactly the wireless hardware is communicating between the two devices. They also still use a form of a MAC address, a network address, and a PAN ID, which basically is the local network that the wireless device would only basically talk to. So it doesn't try to talk to a different network because everything's on wireless. And here's a sample just to show you, just so that you guys can kind of see a little bit of exposure to it. Wireshark displays it in a very similar way, but then you'll notice that it looks functionally very different, but for the most part, the packets, the way it's laid out, still pretty much the same. You'll get your IEEE network layer here, and then it jumps kind of straight into the application layer because it doesn't have a lot of the internet protocol types information there. But you'll still see your source information and destination information. So you got your source MAC and then destination MAC. Wireshark does recognize Zigbee and IEEE 802.15, but within the program, so you don't really have to do anything special if you happen to get a Zigbee protocol packet. It does break it down to you. And same thing, you can see the information, and in this case, the data is encrypted, so it's not going to make much sense to you unless you have the decryption keys and all that to get the information out of it. Okay, and then that kind of ends with the PowerPoint slides, and I was going to jump right in. First, I was going to try to see if there's any questions before I go in there. Let's see. Okay, let's see. This is what does Ethernet 0 refers to as the exact same base which is used. Okay, looks like people are answering questions inside the chat. So is it correct to say Wireshark has to be connected directly to wherever you want to scan for a network? Can you reach a, let's say, router connected via OS? Yeah. So Wireshark, yes, you have to be basically directly, somehow the packets have to come to you, right? And that's kind of where I was saying that where a mirror port comes to hand, right? So if you're connecting to a network, that network has to somehow direct traffic to where you're sniffing, right? So in a way, you do have to be directly connected because you do need that connection to the network, and the network on top needs to direct whatever you're trying to capture to you. Otherwise, you're just capturing traffic from your computer, and anything that happens to be on broadcasts wherever you plugged in. And that's generally what you're only going to be able to see. But if you want to see, let's make it an easy example, the person sitting next to you, if you want to see his traffic, that switch that you're both connected to, that switch has to say, be configured to say, you need to grab your neighbor's traffic and also direct it to be fed into your network connection so that your computer can actually pick up the traffic from the person sitting next to you, if that makes sense. Let's see, I think that was in for questions. There's another one. What is preferred capture device for Zigbee capture? Can this be done with SDR? Yeah, you can do that with SDR. You can purchase probably should have this off the top of my head. There are dedicated Zigbee traffic capture USB devices that you can buy. I can't remember off the top of my head. If you shoot me your email, I can look that up and try to figure out what they were called. But they sell them on like Amazon, and I think if you go to HackRF's website, I believe there was one on their website as well that captures just Zigbee traffic. With SDR, if you have like a HackRF, there are open source GNU radio libraries out there that you can just use your SDR and capture Zigbee traffic and then feed that into your Wireshark. That takes a lot more work, but you can certainly do that. Okay, so let's go to, let's see, how do I kill this thing? So if there's any more questions, feel free to just speak up because I can't see questions when I'm just looking at this. What am I looking at now? All right, so Telnet. So some of the things I just want to show real quick. I'm basically just doing this on the fly, so excuse me if this is a little bit too rough. So here I can see, right click, I can do like a follow TCP stream. Here you see if there's a fake user. So if I was the hacker and then I captured this off of somebody's computer, and now I can see your Telnet session that you were using a login called fake with a password user, and I can kind of see what you can see and what you're trying to do. I can see you're trying to ping some computers over here, right? Oh, that's for going. I can't close this. There it goes. Let's see, let's do it clear. Let's use some of the other. That is so weird. Must something to do with the presentation. I can't scroll either. Okay, so you can kind of see some of the information from Telnet. Let me select the Telnet packet here. There we go. So here you can see the Telnet data, and I already told you there's like RN, so you can do this individually. Show you a HTTP one. So some of the things I was talking about, like endpoints, I can do endpoints. And Wireshark was telling me, well, looks like it sees 3 different devices in this PCAT capture. I can also go to the TCP section of it and kind of see a little bit more details of ports. Sort of like, should be able to sort that. Good. You can see, how much packet information is going through, and this is kind of good to see, if you're looking for someone that was, let's say, using a lot of your bandwidth or something, and you just kind of want to see that if there's like exfiltration, you can go maybe to the largest bytes X leaving your network, or if you're just looking for, the smaller packets, just to see, say someone was kind of using network HTTP, but they didn't really do much with it. Maybe that could be a little bit suspicious, or you see IP addresses that you don't recognize and they're hitting your server. You can kind of investigate a little bit. Other things you can do. What I was showing you earlier was you can look for HTTP files. So I know I kind of did that a little bit quick. File, export objects, HTTP. And here you see, okay, I see an HTML file. I see some JPEG files. And you can see, notice in the background, when I click on a particular item, Wireshark immediately goes to the item. So I can hit cancel here. I can see, okay, it looks like there was a request here and it was grabbing a JPEG image. And when you do the extract, let's do this all the way. Let's just save as. This must be a Zoom thing. Why can't I click? Okay, hold on a sec. I'll just go to the files that I already did. Luckily, I did that. So when we extracted the files, you can see the images that was able to steal off of Wireshark and actually see if someone was actually doing this unsecure network traffic. You can actually see what they're browsing and what they're looking at, or even potentially more dangerous, like let's say like a server configuration files or Excel files that they're just getting off of websites and stuff. And you can also have access to it just because you had the PCAPs. Let's see what else. Another one is from one of the other websites. I'll share the link here shortly. Is you can actually see examples of some attacks. In this case, it's just SIM scanning, so it's not really attack, just more probing. And same thing, if you go here to conversations, you can see that all this is basically just one computer talking to another computer. And if you come here, you can see the various, why can't I sort? Okay, I can't sort this right now. But if you could sort this, if this computer is cooperating with me today, you can sort it by, what kind of ports is this thing doing, and then you can analyze, the packets and stuff. And you should be able to sort, I was able to sort this earlier, by, if there's packets going out and packets are not coming in. So from a scan perspective, this one computer is trying to scan another computer, and the other computer just basically doesn't respond, means that service is not available or it was blocked. And then if it does respond, I believe this is one of the ones that did respond. Packets out, packets coming back. So it looks like they were scanning port 53, and the destination PC did respond back. So it looks like that port is open. Same thing with port 80. And let's say like 139 was empty, 23 is empty. So you can kind of see this used a lot of the tools to your advantage when you're trying to just do a quick analysis of the packets, just to get a quick lay of the land. Let's see. Let's see what happens if I follow the stream. No, there's no streams to follow because nothing responded. Okay. Another example to the Zigbee stuff. Same thing. So you can see, like this particular capture. You can see this device is operating on a PAN ID of 3359. Yep. So you can see which ones are grouped together, who's talking to who. So this is the kind of stuff that you can use like on like the home automation type stuff. If their devices use Zigbee protocol, you can sniff it and kind of see, is the device that's being installed and used, do they use like unsecure protocols or something like that, where Zigbee is not securing the information. But in this case, the packets, I'll show you. in this example that the payload is, like Wireshark reported, is encrypted. So here, this information is kind of useless to us because we don't know what this means. So that's kind of like a validation, whether or not the installation was done correctly. But there are other ones that you can actually buy kits on and program the Zigbee yourself. And you don't have to make it encrypted. And then that's when you can capture like actual data that you can read and manipulate, and then send back to the other Zigbee device, and it will actually respond because it's not encrypted. And that's kind of stuff that you can find out when you just kind of play around and try to study a little bit on various types of protocols. Let's see, I think that's it for that. Let me go back to, okay, there's no additional questions. So I'm kind of going to open it up a little bit to anybody else has, I guess, questions they like to ask, or if there's something you want me to show you that that you want me to expand on a little bit more. And I went through a little bit. While I'm waiting for that, I'll paste the links. And I just pasted the links to the some of the repositories that you saw that I was using for the PCAPs here. So like I said, one was basically ICS focused. Another one was the Wireshark, where a lot of generic stuff. And then the last one, another GitHub from Chris Sanders. He has a lot of ones where it has samples of like attacks. So if you want to see what particular certain attacks look like, you can just kind of download his repository and just kind of play around there. And another question here. Let's see. Wireshark is a great tool, but unfortunately for both the good and bad parties, how do you detect the presence of Wireshark on your network? Well, I guess you really wouldn't. What you might see is just more of a connection of the laptop itself. But if they do it right, the laptop wouldn't be broadcasting any information on the network itself. Because what you'll see when someone plugs into the network is that the OS would do some of the initiation on the network, and you might be able to catch that. But otherwise, if it's just completely passive, and if they're like using a specialized tap or something like that, you're not really going to see it, because the switch itself is just going to basically pass along the information, and you're not going to see their packets, but they'll see your packets. If that makes sense. Yep. Okay. Let's see. Is there any other questions? All right. All right. I think I'll pass it back to Veronica. She's still around.
I am still here. And I thank everybody for joining us today. And thank you, Alex, for hosting. We really appreciate it. Please, if you have any additional questions, feel free to reach out to us and we can field those questions back to Alex. And we have one additional training today starting in the next 7 minutes. So feel free to hop over to the next one. And I believe that's Nmap training. So if you want to join us at 5 o'clock for that last one, and then a reminder, we have our social starting at 6. So again, thank you, Alex, and thank you everyone for joining. Have a great day.
Thank you.